This problem combines many important ideas from mechanics, so I thought it would make a great video. A string is attached to a block resting on ground, and its other end is pulled vertically upward with a constant velocity. What is the minimum pulling velocity required so that the block just lifts off the ground? I will try to not only explain the question, but also tell how to actually think in these questions. So, what is our plan? First of all, the block must lift off the floor. That means there must exist some vertical force acting on block. Clearly, we can see that it is none other than the vertical component of tension force. So if we find this force, then all we have to do is equate T sine theta equals mg. But how do we find T sine theta? Can we find the horizontal component? Well, yes. If we find the horizontal acceleration, then we can equate T cos theta equals max. But now, how do we find ax? Try to think what are the ways of finding acceleration. The most obvious one is dv by dt. So we need to find horizontal velocity vx. And how do we find it? Well, constant motion. Constant motion is simple. It says that the velocities along the constant must be same. Like in this case, the constant is along the string. The upper end is moving vertically up with velocity v0, and let the lower end be moving with velocity vx horizontally. So the velocities of the points along the string are v0 sine theta and vx cos theta. Equate both of them. So we have vx equals v0 tan theta. Now ax is dvx by dt. So differentiating vx with respect to t, we get this relation. This is all fine. But what about d theta by dt? How are we going to find it? In a straight sense, it is nothing but angular velocity of the string. So in order to analyze, we can assume it to be rotating about a point for a split second, suppose p. And as v equals omega times r is valid in this case, we can apply it on the ends of the string and get omega from these two equations. Now plug it in our ax, and thus we finally have an equation for ax. Now according to our plan, we had to find horizontal component of tension using max. So again, plugging in ax now, we get equation for tension. And finally, applying the lift-off condition and simplifying the relation, we have final expression for minimum velocity v0.